All right, well, we are moving right along from where we left off before winter break, and we left off with looking at trig identities and proving using all the different types of identities, basic identities, and Pythag identities. But we're going to kind of break away from that for a little bit in the middle of chapter 3, and we're going to look at solving trig equations. I broke this into two parts. So part 1 is using standard algebra techniques, and then part 2, which you'll do later this week, is with factoring. So what I would do right now is if you think about where we kind of have been this whole entire chapter, it's really revolved around the unit circle. So if you can remember the little things like are all, come on, pen, all students take calculus. To help you remember, will the value of the sine, cosine, tangent, etc. of an angle measure be positive or negative? So please remember that. One of the things that I would probably write also on your notes is that remember the sine of theta is equal to the y value or the y coordinate. The cosine of theta is equal to the x coordinate. And the tangent of theta is equal to the y over x. So if you can remember, those are a couple things that might help you. What I would do is to honestly do this without just copying my work. But if you can remember about our first quadrant, and if you really remember those coordinates for 30, 45, and 60, then you can really work yourself around the other quadrants. So I honestly would pause this video, and you're not going to see me fill this in right now. If you want to check all of your answers, which I strongly advise you to on this circle, my filled in notes um, are in Canvas right where this video was located. So pause, do the circle, check it, and then come back. Okay? All right. So now that you've completed that circle and have kind of reminded yourself, once again, these are all reviews. So I would do these 3 examples and then check with my work, but I'm going to do them right now just in case you were struggling. Um, but we have the cosine of x equals negative radical 3 over 2. And so as soon as I see that, I'm thinking we're probably going to use a multiple of 30 or a 60 degree. So if I think about where that would be located, we have our radical 3 over 2. And so since the cosine is the x value, that would be using a 30-degree angle. But the problem is that it's negative radical 3 over 2. So I know our answer can't be 30 degrees, but I'm thinking we need to look at those increments of 30 degrees. Now keep in mind your answer needs to be in radians here, so that's why it's important to know what those degree measures are in radians. So if I look at my unit circle, the value of our angle measure, which they're calling x, so don't get that confused. We could call it theta, you could call it x, whatever variable you want. Don't get that confused with the x coordinate of the angle measure. But x would be 5 pi over 6 and 7 pi over 6. So we have 2 angle measures that meet that criteria. For number 2, with cosecant of x, we have is equal to radical 2. I'm thinking that that's going to be some relation to a 45-degree angle, which is pi over 4. Now, if I'm working with cosecant, I'm going to immediately think that the reciprocal would be the sine of x is 1 over radical 2, which is equal to radical 2 over 2. So we know that that's definitely our 45-degree angle. Now it was positive, so that means I can deal with positive pi over 4. And then all students take calculus. That is going to be positive also in our quadrant 2. So that means our second and only other answer would be 3 pi over 4. And finally, for example 3, as soon as I see that cotangent, I'm thinking that the tangent of x is going to be the reciprocal, so that would be negative 3 over radical 3. And when you simplify and rationalize that denominator out of there, this would be negative radical 3. So once again, I'm thinking with that radical 3 involved, and we have tangent. So if I think about what's going to give me a radical 3, well, if I do radical 3 over 2 and I divide that by a half, which is the same as radical 3 over 2 times 2 over 1, that's radical 3. And so since tangent is y over x, we're looking at our 60-degree angle because we want our y value to be that radical 3 over 2. So that means if we think about it, our answer has to be negative radical 3. So with our all students take calculus, we're looking for where is tangent negative. So that's going to happen in quadrant 2. So we have 2 pi over 3. And that is going to happen in quadrant 4 with 5 pi over 3. So I promise this is going to relate to what we're doing on the next page. So I'm hoping this kind of brings back all that stuff that we did in chapter 2 really into 3. So here we go. So all of that was review. So now we're actually going to get into the concept or the new concept of today. So if we take a look, we're now going to start solving trig equations. And this might seem a little crazy at first, but I think you'll kind of be in your comfort zone soon. So for examples 3 and 4, we're not going to solve for anything right now. We're going to just backtrack, and it says determine if the x value is a solution. So what we want to do is basically just take this value of x that they're giving us, and we're going to substitute it into the equation. And the one thing I want to remind you is you have got to be able to do this without your calculator, because the whole idea is to be able to start doing some of this in your head. So we have the sine of pi over 3, which this is why I really tried to review. If you remember, pi over 3 is 60 degrees. So we would do 2. Now we have to be able to do the sine of pi over 3. And if you remember, sine is always equal to your y coordinate. And so the sine of our 60 degrees is going to be radical 3 over 2. So that's why it's important to be able to do this without your calculator, because we don't want decimals and all that ugly stuff. So now when we multiply 2 times radical 3 over 2, we get radical 3 minus 1, and there is no way that that's going to be equal to 0. So no, pi over 3 is not a solution to this equation. So for number 4, we have 2 times the cosine squared of 4x minus 1 equals 0. Once again, we're just going to see, is pi over 16 the answer? Remember, one of the answers. It's not kind of like back in Algebra 1 where we solve for x and get one answer. So it's a little bit different. So when we do cosine squared of 4 times pi, substitute that right in as you normally would. And I would definitely simplify this first to pi over 4. And remember, cosine squared, so we need to take the cosine of pi over 4. Remember, that's what that means as far as to kind of help you do this properly. So we are going to be taking the cosine of pi over 4, or 45 degrees first. And this one's a little bit easier as far as memorization. So the cosine of 45 degrees, aka pi over 4, is radical 2 over 2. Then, by order of operations, we're going to square it. So that's going to give us 2 times radical 2 over 2 times radical 2 over 2 is going to give us 2/4. I'm running out of room, so I'm going to come over here to the side. So when we have 2 times 2/4, well, that's just 1. And so 1 minus 1 is 0, so we get down to 0 equals 0. So yes, pi over 16 is one of the solutions to that equation. Okay? So what we're going to do now is really for the rest of our kind of notes or lessons is we're now going to solve these algebraically. And so it says solve them without your calculator, and we have to find all the solutions between 0 and 360, which is 2 pi. So we need to not just remember that there's going to be possibly more than one answer multiple times, okay? So I'm going to do these first three with you and kind of, without maybe pausing because it is brand new. But you'll be surprised to how similar this is to just solving basic equations for x. Okay? So in number 5, if that sign of x was not there and it just said x, I think our first goal would be to subtract 1 from both sides. So we would have 2 times the sine of x equals -1. And then we would divide both sides by 2. And the difference is we're not getting x by itself, we're getting sine of x by itself. So now you have to basically, without your calculator, ask yourself the sine of what angle measure is equal to -1/2. And this is why we did those 3 examples and the unit circle on the front, because we're right back to where we were. So if you're asking yourself, when is the sine of x going to be equal to -1/2? You have to think, well, the sine of that angle measure is the y coordinate, and that is going to happen at 30 degrees, which is pi over 6. But our answer is negative, so it can't be in quadrant 1. So our two answers are going to have to land in quadrants 3 and 4, and that's going to be 7 pi over 6 and 11 pi over 6. And those are our two answers. So really, the algebraic process is the same as it was that you learned back probably in 6th grade with order or with inverse operations, but now you just really need to have these trig, angles, and radians memorized. So for number 6, I think you probably guessed it, we're going to add 3 to both sides first, and we are going to have 4 times the cosine squared of x equals 3, and we're going to divide both sides by 4. And that gives us the cosine squared of x equals 3/4. Now, we're not trying to get x by itself right now. We're trying to get cosine of x by itself. Well, it's being squared. And just as you did in algebra, the inverse operation is to take the square root of both sides. So when I take that square root of both sides, what we need to remember, just like in Algebra 2, is that we don't know what type of number, positive or negative, was underneath the radical. So we have to be careful in making sure that we have plus or minus radical 3/4. So if I take a look, I have the cosine of x now on the left, and I have plus or minus the square root of 3 over 2. So what's interesting about this final answer is we're asking ourselves, the cosine of x, aka the cosine of what angle measure is going to be positive radical 3 over 2 or negative? And so that really covers every quadrant. So we're going to have 4 answers here. And so the cosine of an angle measure equals the x coordinate. So that's going to push us where the x coordinate's radical 3 over 2. So that's 30 degrees, aka pi over 6. And so we have pi over 6. Well, then we need to move to quadrant 2. And the angle there would be 5 pi over 6. Then we need to move to the quadrant 3, which is 7 pi over 6. And in quadrant 4, it would be 11 pi over 6. And then we don't go on. There are obviously infinitely many answers, but because it's putting us in this interval between 0 and 2 pi, that's why we stop at 4 answers. Okay? All right. So I don't think I'm going to have time on this video because it stops me after 15 minutes. So what I'm going to have you do is if you want to try 7, 8, or 9 on your own, and maybe just see what your gut instinct tells you to do. If not, that's fine. You can follow along with the video. But I'm going to end this part of the video so that I can start the next one without running out of time. So the next one is right under this one on Canvas. All right.